Assalamu alaikum. My name is Mohammed Iqbal. Today I am going to implement 2-bit comparator by using Proteus. First of all, make a new project file and then rename it. I will rename it as 2-bit comparator and I will save it on desktop. Okay. Next I will use A3 page configuration. So this is our border in which we will make 2-bit comparator. For this purpose, I will just add the ICs which will be used for this purpose. These are the ICs and okay, or NOT gate. You have to be careful while selecting the components that its simulator model is also written here. If it is not written, it will give an error. Simulator model not defined. Okay, and then 7004 7404 edit 08. Okay, I have added almost all of them. And for this purpose, I will use logic toggles and logic props. Logic prop, logic toggle. Okay, for the input, you can also use 5-volt DC supply button and a LED for input. But for your understanding, I am using logic toggle and logic props. I will simply place them here and I will simply by text script mode I will write their name over here with constants. I will just write here the name. I will just rename it as B. Okay, I will just stay so that the font size is not okay. D and D. Okay, D input. I will resize it. Okay, now first combination which I am going to implement is function 1, AB is less than CD. For this purpose, first of all, I will attach a NOT gate with my inputs. Almost all the inputs will require a NOT gate. Okay, let me just configure it so that it should look neat and tidy. Okay, first I am going to implement is AB is less than CD. That AB will result in less than CD. Okay, first of all I will need a 3 input AND gate. This is a 3 input AND gate on which I will simply attach it with the inputs. Okay, let me just set it, and it is a D input. It should be better to start from here. Okay, this looks good. Again a 3 input AND gate. This time I will attach this with the second terminal with the C. and third with simply with D. Okay, D. D. Okay, and now I will use to input and gate, and I will simply attach this with this and with the second terminal with C. Okay, this looks good. Now, before before I write equation on it, I will just verify whether it is giving a correct output or not. Okay, I have forgotten one gate. That is three out input OR gate. Three input OR gate, and now I am going to verify the output. Okay, let me just run it. CD will be greater than AB. It is proving right that CD is greater than AB. If okay, it will not work. Now it will not work because both are equal, but it will work. Okay, let me just try one more combination. It is working. So it is so our circuit is working well. So let me just write the equations on it. So that's why, for your understanding, so you should understand it easily that what is happening, because the circuit would become very complex at the end, and at that time understanding would become is a very hard task. Okay, B R, that is B complement. Okay, this is C complement. This is D complement. Okay, now I will write the equations on it, that from which equations I have made this circuit. Okay, this is I will just copy from here and ABD, and I will okay, now I will just replace the variables. Okay, now I will just increase. So what is the importance of writing the equation? By seeing the equation, a person who have not designed this circuit can understand that what is happening in the circuit. So for him, it will become very easy to understand that what is the working of a circuit and how the circuit is working. So that's why it is very important to write now a resultant equation. I will write resultant equation at the end. Okay, we will write it now. So A bar, B bar, and D. So we have added it, and AND gate, we have used an OR gate for it. B bar, C and D. Okay, and now I'm using A bar C. Okay, this is the resultant circuit, and okay, I will label what it is. It is a AB is less than CD, so you will understand that what output it is giving. Okay, the next thing that I'm going to implement is AB is equal to CD. For this purpose, I will use an exclusive OR gate, and I will simply use two and OR gate, and I will simply configure it with a terminal. I will attach it with a terminal A and then with a terminal C of simple wiring. But as you can see, the circuit is becoming complex as we are moving forward with as we are progressing. Another exclusive OR gate for which one terminal will be attached with D and the other will be with the P. Okay, according to the equation we will use two NOT gates. So the output these OR gate, so exclusive OR gate will be inverted by an OR gate, and at the end I will use an AND gate. Okay, for a better output. Now it looks good. Now it is looking good. Okay, for some neatness, I will wire it again so that the circuit looks good and presentable. Okay, now it looks good. Okay, now we will simply use logic. This is the circuit for AB is equal to CD. Okay, as you can see that both AB and CD are 0, 0, that is they are equal, so it is giving 1 at the output. So in this way, okay, now it is 0 because I have changed A. I am giving 1 at the A and 0 at A, B, C, D. Then it is giving 0 at the output, so they are not equal. Now it will give 1. Now it will give 0 and 1. Okay, that's it. Now I will simply write equations for it. I will stop simulation and I will write an equation A X or C. As XOR symbol we do not have an circle plus for XOR, so we simply write XOR. So that for our better understanding. Okay, and now with the BD, now with the BD. Okay, let me just increase the size of its font. Okay, now I will what the effect it will get. Okay, and this the output with which the exclusive OR gate will be inverted by a NOT gate. That's look good. Okay, now it is fine. Okay, now let me just adjust the text. Okay, and I will just change the variables. Okay, and and a complement with it. So at the end, I will tell you that what we have achieved by writing these equations. Now it is looking uh, it is looking weird to write equations like this, but it will help out when we complete the circuit, and I will tell how it will help us out at the end. Okay, now I will be writing the combination for F2. That will be AB is equal to CD. And now I will just, okay, that's look good. Okay, the last combination which we are going to try is AB is greater than CD. For this purpose, we will use two 3 input AND gate and one 2 input AND gate. First of all, I will place this AND gate and I will simply attach it with A. A will simply attach it with A, and this with the C bar. For the first time, I'm using C bar in this circuit. So this is C bar, and the next I will use is a 3 input AND gate. 3 input AND gate. I will first attach it with A, and okay, let me, okay, as the circuit has become very much complex, so I'm not finding the way to go to my required place. Okay, now, and the last is D bar. D, for the first time I will be using D bar as I have not used before. Okay, now there is some problem as there is some obstruction in line. Okay, let me just settle this issue. Now you can see that, okay, now it will be easy. So this is a problem when the circuit become too large. It becomes difficult to place the components. Now one more 3 input gate. It becomes a tough task at the end for the circuit to join it because the circuit becomes complex and you didn't find a way to go. So making large circuit on the Proteus. Okay, now the last which I will attach is with the B bar, with the D bar. Okay, now this is D bar. Okay, now you can see before writing the equations, I will simply test whether my circuit is working well or there is some error left, which I have to resolve, which is a tough task, but I have to resolve. Okay, now I will test my circuit. This will verify that whether AB is greater than CD or not. Okay, AB is greater than CD. Okay, now as you can see, the circuit is perfectly working, and it is also verifying that AB is greater than. As you can see that now I will show you the working, but before showing you the working, I will just write the text on it so that you could understand it easily. Okay, it is not text writing mode, and this is a C complement, and this is AC complement, and this is ABD complement, ABD complement. Okay, I will simply copy the text from here and as I write. Okay, and now this is B C bar, C bar, C bar D bar. Okay, now at the output we are getting AB, ABB, ABD bar, A C bar, plus, because we have used an OR gate, so we will use a plus symbol for it, and B C bar D bar. Okay, now and okay, now I've labeled it, and last labeling is function F3, which is AB is greater than CD. Okay, as you can see that 00A is 0, B is 0, and CD is 0. So the F2 is giving one that it is working as both of the A and B and CD are equal. Now I will just give one at the input A. Now you can see that the F3 function is working. This means that AB is greater than CD, so our circuit is working perfectly. Now I will simply give one that they have become again equal, and one. I have given one at the C and one at the D, one at the A and 0 at the B. So this means that CD has become greater than AB. F1 condition has become true, and it is giving 1. Now again, if I will give 1 at the input, input 1, input A, and 1 at the input B, 1 at the input C, and 1 at the input D, both have become equal, and F2 has become true. Now if I, okay, now AB is greater than CD, so F3 is working, right? So this is a working of a 2-bit comparator. I have designed it simply by using gates, simple gates, and now the time comes that what is the importance of labeling these. As you can understand that this circuit has been designed by using the equations which has been derived from a Karnaugh K-map, and truth table Karnaugh map has been made by using truth tables. So you can see that by the equation you can recognize that what type of combination is used here, and how this circuit is designed by using equations. So as you can see, the circuit has become very much complex at the end. So if any other if any other person is seeing the circuit, he will find it complex. But if he knows how we can make the circuit from the equations, so by seeing the equation he can easily understand the circuit. We can easily understand these type of complex circuits. So at the end I will simply write my name and roll number. Okay, and okay, and now okay, this was the working of a 2-bit comparator by using 4 inputs, and using simple logic gates. Thank you.